Okay, so in this lesson, we're looking at congruent chords and how that's related to central angles and arcs in a circle. So looking at this diagram, what they've told us with the labeling is that AB is congruent to CD. So they've told us that AB is congruent to CD. So these are chords. What this means is that we can assume then that the central angles are also congruent. So that means that I know that this angle and this angle that open up to those congruent chords are also equal. So I can take these measures that they've given me, 6x minus 8 and 9x minus 19, and then that will allow me to solve for x. So I can subtract 6x and add 19 to solve for x. So that means that 3x is equal to 11. And so if I divide both sides by 3, x is 11 over 3. If I wanted to write that as a decimal, that's 3.6 repeating. Okay, so similarly, remember that central angles and arcs are equal. So the same thing will happen backwards and with the arcs. So if I have in this diagram, they're telling us that our central angles are equal. So notice they've told us that. And so I can do this backwards. So now that means that AB is equal to CD, that my chords are also equal. Okay, so I'm able to set 9x minus 19 equal to 4x plus 6. So if I solve that for x, 9's bigger, so I'm going to subtract 4x, which gives me 5x. And then I'm going to move the 19 over by adding. And so that gives me 25. So dividing by 5 gives us that x is 5. This one wants us to also find AB. So if I look at AB, AB is this one, the 9x minus 19. Remember that they're both equal, so I can choose to plug into either one. So if I do 9 times 5 is 45 minus 19 should give me 26. Remember that I could also do 4 times 5 is 20, plus 6 is 26, so I could plug into that one as well, just because they're equal. Okay, so in those two, we essentially just had converses of each other, and we flipped the order. So they told me the angles were equal, so I can set the chords equal. They tell me the chords are equal. I can set the angles equal. For this next one, it's chords and arcs. Remember, arcs and angles are the same, so I can still say they're equal. But as long as I have congruent circles, so if they tell me my circles are the same, that means their radii are exactly equal. So that means that I can make these same assumptions. So they're telling me that arcs EF is congruent to arc CD. And so that allows us to say then that the chords are equal. EF is going to be equal to CD. Okay, so I can set those two things equal. So 7x minus 18 is equal to 3x plus 6. So if I subtract 3x from both sides, then I'm going to get 4x, which means I want to add 18. is equal to 24. So then I would divide both sides by 4, tells me that x is 6. They want me to find DC. Again, DC is this one, but I could plug it into either. It's a good idea to plug into both to check. So 7 times 6 is 42. Minus 18 is 24. And that's the same as if I were to plug a 6 into here. 3 times 6 is 18 plus 6 is 24. Okay, so the last theorem is a little bit different. And in my theorem list, I actually left off this piece. And so what is also true is that chords are equidistant from the center of the circle, or the centers of congruent circles, if and only if they are congruent. So if I know that AB is equal to DC, then that means that SE is equal to SF, and vice versa. Chords are also bisected by radii that are perpendicular. So when I have a radius that's perpendicular, this is my R, and it's perpendicular to this chord AC, then it's bisecting the chord and the arc. So if I know that this arc AB, this one, is 5x plus 9, and I know that the entire arc from A to C is 16x plus 6, then what I can do is set AC equal to half of, AB equal to half of AC. Okay, so I can do 2 times AB would be equal to AC, or I can do AB equals half of AC. If I think about AC as 2 even numbers, so that one's probably the better one to do, right? If these were odd numbers, I would want to do the first formula. But since they're even, let's do the second. So 5x plus 9 is equal to half of 16x plus 6, or 5x plus 9 is equal to 8x plus 8. Okay, so if I solve this, I want to subtract 5x. And so that'll give me 3x over here, which means I want to also subtract 8. So x is going to be equal to 1/3. If x equals 1/3 and they want me to find BC, remember that BC and AB are equal. And so I can plug in to AB in order to get BC. So I'm going to do 5 times 1/3 plus 9. So 5 times 1/3 is 5/3 plus 9 is, so this is 5/3 plus 9 is 27/3. So that's going to be 32/3. which is about 10 2/3, or you could round it to 10.7, something like that. Okay, so that one is 10 2/3 degrees for the measure of arc BC. Or you could do it as 10.7.